Hey, ladies and gentlemen, welcome to 6.4. Let's get started right with your bell ringer. This is all multiplication. So I'm going to multiply 3x into all three of these. I'm going to get 18x to the fourth. I'm going to get 15x squared. And I'm going to have minus 30x. Inside now, I'm going to do negative 5. So I'm going to do the same thing with negative 5 to all these guys. That's minus 30x cubed minus 25x. Sorry, squared is not right. It's just x and plus 50. All right, I'm combining like terms at this point. There are no x to the fourths other than this 18. There are no x cubed, so I'm going to rewrite minus 30x cubed. I have a 15x squared right solo, and I have a couple pair of x's here to make 55x, and plus 50 on the caboose. So there is numero uno. Let's go to 2. Okay, I'm going to FOIL the first two together. So it's going to give me 4x squared plus x. And now I'm going to FOIL negative 3 in here, so that's minus 12x minus 3. Still going to have my x minus 7 on the caboose. I'm not going to multiply that yet. I'm just going to combine my like terms to get negative 11x. I am now going to distribute my 4x squared into both of these. So that's 4x cubed minus 28x squared. I am now going to distribute my negative 11x in, so that's negative 11x squared, and 77x. And then I'm going to do negative 3 times these guys. Negative 3x plus 21. Alright, so we have 4x cubed minus 39x squared plus 74x and plus 21. And that's where you would stop. So hopefully that's kind of like a busy problem, keep you busy, because there's a lot of multiplication. Okay? Going down here. Your EQ, your essential question would be, how do we use factoring of polynomial expressions to solve for problems? And how do we factor and solve polynomial equations of a higher degree than, say, x squared? So now you're going to be looking at every single type of polynomial in the world. And it gets kind of tough at times, but make sure you always start with the GCF. The GCF at number 1 here looks like 2x. So I'm going to pull a 2x out of each. So I'm going to have 2x out the front. That'll leave me with x squared minus 2x plus minus 15. I don't know why I wanted to make that plus. Equals 0. Okay, I can put 2x equal to 0 and finish that. So x is 0. I'm going to factor down this trinomial now, because that's going to be x times x. And then I have plus and minus. I want numbers that multiply to be 15 have a difference of 2. So that would be 5 and 3. 5, negative 5 and 3 make negative 2. 3 times negative 5 is negative 15. So I have x plus 3 equals 0, and I have x minus 5 equals 0. So my two other x values will be positive 5, and this x will give me negative 3. Okay, so I have my 3 answers. This is the number of answers. Either are going to be 3 because my exponent was 3. And my 3 answers are 0, negative 3, and 5. There's my answers for x. When I look at example 2, there are going to be 5 solutions. A lot of them are going to be doubled up. Let's start with the GCF here of 5x to the 4th. That will leave me with x minus 1 equals 0. Okay? So I'm going to set 5x to the 4th equal to 0. Divide by 5. X to the 4th equals 0. So I take the 4th root. So x is equal to positive negative 0, basically 0. X minus 1 equals 0, so x equals 1. So my values for x that work would be 0 and 1. Now I did say there were going to be 5 answers. This answer here, counts for 4 answers because I took the 4th root. Okay? This counts for 1 answer. 4 plus 1, that's 5 answers. So 0 is counted 4 times because it was x to the 4th. Let's jump down to example 3. to set this guy equal to 0 by subtracting 48x squared over. I'm going to pull a GCF out of 3x squared. So this is going to leave me with x squared minus 16 equals 0. 3x squared will equal 0, so x squared equals 0. So that would be positive negative 0, which is just 0. That's 2 of my answers. I have 2 more to go. I'll set x squared minus 16 equal to 0, x squared equals 16, x is equal to positive negative 4. So my 4 answers, 0 is counted twice because x squared equals 0. And you would have positive 4 and negative 4. There are my 4 solutions. Okay, example 4. Oh, no GCF here. This looks like a straight up factoring problem. This will be x squared times x squared. Minus plus is minus minus. 3 and 4 multiply to be 12 and add up to 7. So I'm going to have x squared minus 3 equals 0. I'm going to have x squared minus 4 equals 0. X squared equals 4. X is equal to positive negative 2. Over here, I'm going to have x squared equals 3, so x equals positive negative square root of 3. So my solutions are as follows. So I have positive root 3, I have negative root 3, I have 2, and I have negative 2. Okay, there are my 4 solutions, 4 answers. Good to go. The bottom problems are actually pretty simple. We're going to use factor by grouping. It's always a tip-off when you see 4 terms. Count. 1, 2, 3, 4. 4 terms. Terms are separated by minus and plus. So we actually know how to do factor by grouping. We've been doing this all year. I'm going to pull out an x squared here. That's going to leave me with an x minus 3. My GCF of these two is negative 3. Leaves me with x minus 3. So I'm going to have x minus 3 times x squared minus 3 equals 0. So x minus 3 equals 0, x equals 3. This will be x squared minus 3 equals 0, so x squared equals 3, which means x is positive negative square root of 3. So we're looking at positive root 3, negative root 3, and 3. There are my 3 answers. Good to go. All right, again, we are going to do grouping here. Remember, this was addition there. So this GCF of x squared leaves me with x minus 1. GCF of negative 2 leaves me with x minus 1. So x minus 1 times x squared minus 2. X minus 1 equals 0. And x squared minus 2 equals 0. So x squared equals 2. X is equal to plus or minus the square root of 2. So my 3 answers are 1, square root 2, and negative root 2. Okay? Alrighty then. Jump down to 7. More of the same. Third verse, same as the first. So GCF of 3x. Nope, not 3x. Just x squared. If you pull an x squared out, leaves you with x plus 3. Pull a negative 4 out here, leaves me with x plus 3. Okay, so we're going to have x plus 3 times x squared minus 4. So x plus 3 equals 0. X is equal to negative 3. There's one solution. X squared minus 4 equals 0. You can set those equal. I'm going to choose the factor this time so you can see more practice with the difference of squares. So x plus 2 equals 0, and x minus 2 equals 0. So my other 2x values will be, this one gives me negative 2, this one gives me positive 2, and I rewrite my negative. There are your 3x values. Negative 2 to negative 3. Alright, now they're starting to give us ones that are just huge, which is pretty big. GCF of a to x to the 4, so that leaves me with x plus 4. GCF of negative 2x squared, so that will leave me with x plus 4. So I have x plus 4 times 8x to the 4th minus 2x squared. I'm going to finish up with x plus 4, so I get negative 4 from this guy. I'm going to pull GCF here of 2x squared out. So that's going to leave me with 4x squared minus 1. So I'm going to set 2x squared now equal to 0. So x squared equals 0, which means x is equal to positive negative 0 when I take the square root. So 2x squared is finished. I am now looking at 4x squared minus 1. That's 2x plus 1 times 2x minus 1. So 2x plus 1 equals 0. 2x equals negative 1. X is a negative half. That guy. 2x minus 1 equals 0. So 2x equals positive 1. So x is equal to a positive half. So your 5 solutions would be negative 4, positive and negative 0, which is just 0, negative 1/2, and positive half. Those are your 5 solutions. Remember, this one was plus or minus 0. So there is the front of your notes. We'll go ahead and move right to the back. Okay, so difference of cubes. This is how SOAP works. I guess I should write it off to the side here. SOAP stands for same, opposite, always, positive. Okay, and how it works is this. We have a binomial here times a trinomial. The cube root of this is A. The cube root of this is B. Now I'm going to use SOAP. SOAP is the same sign. So same sign as plus is plus. Opposite would be negative, always positive on the end. So when I do my trinomial, SOAP tells me my sign. It's opposite, always positive. A times what is A cubed? A times A squared is A cubed. B times what is B cubed? Well, B times B squared. To get this term, multiply A times B. And that's it. All right, so let's do the negative one. I have a binomial times a trinomial. Cube root of this is A, cube root of this is B. Talk about the signs. Same sign as minus. This is a minus sign. All opposite would be positive, and then always positive is the plus sign on the end. Let's get this guy. A times A squared is A cubed. B times what is B cubed? So B times B squared. And then this comes from A times B. Whatever that is. So when you go ahead and do this, once you learn that pattern, life is good. So we got a binomial times a trinomial. This is a perfect cube. This is a perfect cube. This is going to be SOAP. So the cube root of x cubed is x. Cube root of 8 is 2. Same sign. Opposite, always positive. X times what is x cubed? 2 times what is 8? 4. And then I do 2 times x. Finished. Okay. Moving right along. Perfect cube, perfect cube. This is 3, this is x. So, in my binomial, this will be x, this will be 3. Same sign as minus. Opposite is plus. Always positive. Yeah. X times x squared is x cubed. 3 times 9 is 27. 3 times x is what goes in. All right. Perfect cube, that's 2x. Cube root of that is 5y. So they're perfect cubes, we can factor this. So this is going to be 2x, this is going to be 5y, same sign as plus, opposite would be minus, and then always positive again. 2x times 4x squared is 8x cubed. 5y times 25y squared. Okay? 25y squared would be 125y cubed. Then 2x times 5y. 2 times 5 is 10. X times y is xy. Okay? So there's your answer for number 3. Now they're trying to trick us by throwing large numbers at us. The cube root